here are some important features of a periodic trigonometric function. We have something called the amplitude. The amplitude is a measure of half the difference between y maximum and y minimum. So you see here's y maximum in the sketch where the arrow is, and here's y minimum. If we take half of the difference between the two, that gives us what is called the amplitude A. The period, which we usually signify with the capital T, is equal to the x interval for one complete cycle. So in this picture I've drawn for the period of the sine function, we see one complete cycle occurs between the first dot on the x-axis and the second dot. That's called one period. Then it repeats again for a second period, repeats again for a third period. So my sketch actually has 3 periods of the trig function in the picture because we have 3 repetitions, 3 cycles for that trig function. And then the phase shift is another term you want to be familiar with. The phase shift, well, you look at the dotted line. I drew the sine function in its normal position, and then I shifted the entire wave b units to the right. Horizontally, I shifted it b units to the right, and I drew it in a solid graph. So what that's indicating here is that the b units equal a horizontal shift of the periodic wave, and that shift, that value b is called the phase shift. So we're going to summarize what we've just seen here. Thus, given that y equals the number a times the sine of k times x, the amplitude, capital A, is equal to the absolute value of the number in front of the sine, the absolute value of the number a, and the period t is equal to the original period t pi divided by the number k that we have in the given equation. Similarly, for y equals a times the cosine of k times x, the amplitude is the absolute value of the number a, little lowercase a, and the period t is equal to the original period 2 pi divided by the number k.